Alright, good morning, good afternoon, good night to you. Now let's take a look at a couple of questions. Now, John was standing in an air-conditioned room as shown in the diagram below. Air-conditioned room. So let's take a look at the temperature inside and outside the room. The temperature inside the room is lower, is at 20 degrees Celsius. The temperature outside the room is higher at 30 degrees Celsius. So as you know, heat flow from an area of higher temperature to a place of lower temperature. So there will be heat flow from outside into the inside, okay? Outside the inside. Heat flows in this direction. And you know that glass is a poor conductor of heat. So that will reduce the flow of heat. Of course, right now I'm not sure what is the question asking. Is it about heat flow? Is it about condensation? I'm not quite sure yet, so I'm just thinking aloud. John noticed that there were water droplets on the glass surface. Water droplets. This means they must be talking about condensation. Okay. Explain how and where the water droplets were formed. Alright, so it must be talking about, there are 2 points, you have to get 1 mark. 2 marks. 2 marks, right? So how was it formed? I mean, some condensation. When about condensation, it's always what is being condensed. Of course, you know that it is water droplets. Sorry, water vapor will condense into water droplets. And they must condense on a cooler surface. Obviously, there's only one cooler surface here, right? The glass surface. The problem is there are 2 surfaces. Alright, you can see, right? One is on this side, one is on the other side. So which side would be the cooler surface? Alright, and where's the temperature difference? Now, you will think that the layer inside is the cooler surface, the part facing inwards, because it's at 20 degrees Celsius. The problem is if you are inside an air-conditioned room and touch the windows of your air-conditioned room, you don't find that there is condensation on the windows if you touch on the inside. Just like you're in a car or on a bus, and if you touch the insides of the windows, you don't see any water droplets condensing, even though the inside of the room could be at a low temperature, such as 20 degrees Celsius. Now always remember, condensation is not just water vapor to water droplets. It is a loss of heat. So the water vapor need to lose heat before it can condense into water droplets. So losing heat means that the water vapor must be at a higher temperature first, alright, and losing heat to the cooler surface. So at which place would the water vapor, there's water vapor here in the room, because there's water vapor in the air. There's water vapor here in the air, outside the room. Which of the water vapors are in the room or outside the room is at a higher temperature? Outside the room, right? So therefore, the water vapor, talking about where's the water vapor, is outside. So water vapor outside the air-conditioned room will condense on the outer surface of the glass surface. Alright, and become water droplets. So how would I answer this? Let me just get a sheet of paper. You must answer the how and where, right? So water droplets outside the room will touch the cooler surface of the glass, lose heat and condense into water droplets. So have I answered the 2 things? Where was it formed? It was formed on the cooler surface of the glass. And I said now to be very clear, because the teacher doesn't mark me down, right? On the outer cooler surface of the glass. Because I already mentioned is the water droplets outside the room. That should be clear now. We'll touch a cooler. We'll touch the cooler outer surface of the glass. And then now the how part. How is the process of condensation, which is water droplets, lose heat, condense to water droplets. Where's the mistake? I made a mistake here. Water vapor. Luckily I checked. Water vapor. If you spotted a mistake early on and you're waiting for me to spot it myself, I'm glad I did so. Okay, I hope you're glad I did so as well. So imagine if I didn't change, I didn't check my work, then this answer, no matter how well I thought through it, will be wrong. Okay, water vapor outside the room will touch the cooler outer surface of the glass, lose heat, and condense into water droplets. Yeah, 2 marks. Let's check your answer. Water droplets were found on the outer surface of the glass. Okay, you talked about the where already. That's correct. Now, the glass surface, so I can't see clearly, lost heat to the cold room and had a cooler surface. Okay, this part I don't think is necessary, but it's okay to mention it. Alright, there's nothing wrong in mentioning it. Warm water vapor from the surrounding outside the room. Okay, so talk about where is water vapor from. Lost heat to the outer glass surface. Condensed from. Very good. Alright, 2 marks. Good job. Next one. John replaced the window with a double glazed window of the same material. Double glazed simply means there are 2 layers of glass and inside is air. It's usually meant, when people install this in cold countries, it is meant to reduce the rate of heat gain or loss, depending. So in winter time, they want the room to be hot, right? As hot as possible. They don't want the winter time outside will be much colder than the inside of the house. So they don't want to have the heat inside the house to be lost to the environment. So they put double glazed window to reduce the rate of heat loss from the room. During summertime, when it's hot, they don't want the air conditioning because it's really hot outside. Outside is hotter. They don't want the room to gain heat from the environment. So they use, again, the double glazed window to reduce the rate of heat gain by the air in the room. So it can be useful whether it's in a hot climate or a cool climate. Explain why surface 1, which is the outer surface, did not have as much water droplet as in part A. Now, because you understood this part earlier on, this part that says the glass surface lost heat to the cold room and had a cooler surface. By the way, you use cooler. I prefer if you use comparative like cooler. Alright? Because you understand this, now you should understand this part because of the layer of air plus 1 more layer of glass. So therefore, this outer glass, let me just highlight this, okay? This glass surface 1, which is the outer glass surface, it will be getting heat from the environment. Okay, it will be getting heat from the environment. But it will not lose heat to the cooler air in the room as easily, as quickly. It will be much slower compared to this. Because here, when the glass gains heat, alright, from the environment, the heat can be conducted through the glass slowly, but into the air inside. So the glass actually loses heat to the air inside the room. In this case here, it's much slower. The loss of heat by this layer of glass to the interior here will be much slower. Therefore, it will be less cool. This outer layer of glass will not be as cold as this layer of glass. So if it's a less cooler, if this cooler surface is less cool, then of course the rate of condensation will be less. Let's see so how would I answer this? I would say that it's 2 marks, right? Okay. So let's go with the concept. The concept must be the idea that the glass surface 1 is less, this is not concept yet, okay? The idea is less cool than glass surface in part A. Okay. Why is it less cool? So what happens when it's less cool? So the rate of condensation will decrease or will be less than in part A. So these ideas must come out. These two ideas must come out. So, and how to explain this? I need to use the layer of air inside the glass being poor conductor of heat in order to reduce heat gain. So let me try answering this now. Surface 1 is less cool than the glass surface in part A. Alright, so this is my claim. Okay, that is less cool. Because, why is less cool? Because the rate of heat loss to the cooler, to the air conditioned room is less. The rate of heat loss to the air conditioned room is less than in part A. Let me be even clearer. The rate of heat loss by the glass surface 1, okay, I don't want to penalize, so I want to make sure I'm very clear regarding the source of the heat as well as the destination of where the heat loss go towards. So this is where it is the hotter surface right now because it is directly facing the sun, right? So the rate of heat loss by the glass surface to the air conditioned room is less than in part A. Okay, this should give me 1 mark. I'm not yet now. On part A, as the layer of air, which is this one, I don't have to say layer of air between the two glass because it's already stated here. It's a layer of air and glass surface 2 are poor conductors of heat that slow down heat transfer. Okay, a lot of words for 1 mark. Okay, now I explain this first thing already. Why is this less cool? Now I must go to this for the second 1 mark. The lower rate of condensation. So let's recap. Surface 1 is less cool than the glass surface in part A because the rate of heat loss by the glass surface 1 to the air conditioned room is less than in part A, as the layer of air and glass surface 2 are poor conductors of heat that slow down heat transfer. So the rate of condensation on the less cool, I use less cool, you can say warmer, less cool surface 1, glass surface, the rate of condensation on the less cool surface 1 is less than on the cooler glass surface in part A. So the rate of condensation on the less cool glass surface 1 is less than on the cooler glass surface in part A. I think I don't have to mention the less cool. You know why? Because I mentioned here. So the rate of condensation on the glass surface 1 is less than on the cooler glass surface in part A. This will give me the second 1 mark because I'm talking about the lower rate of condensation. So you see how I'm doing it? First, I must know what goes into the 2 marks. Then, I phrase it as clearly as I can. As of now, I can't find a shorter way to describe it because it doesn't seem very long. Of course, my handwriting is a bit larger than yours. You see, in one sentence, I have only 6 words. Like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Yeah, you can squeeze in more, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So for you, probably this you will not use as many lines as Mr. Long. Okay. Now you have one more question, I think. Oh, there's one more here. Okay, I already explained this, so no need to have this. Block M was hung on spring L as shown in diagram 1. So this one, spring L, same spring. Oh, okay. So it actually stretches the spring, right? When you put a magnet here, this one, the length here decreased. Notice the dotted line is going to help you to see that this mass actually went up. So there must be a repulsion. So therefore, that only magnets can repel another magnet. Only magnet can repel another magnet. So therefore, this must be a magnet. So what are the following forces acting on spring L? So this mass is still pulling down. So there is still gravitational force here. Alright? The spring is being compressed. So there is still elastic spring force. So these two forces are definitely there. No frictional force. You don't see movement in terms of sliding across the surface. So there's no frictional force. Alright? There is magnetic force repulsion also. Because here there must be repulsion, what? But it's on the spring, right? So you're right. There's no magnetic force repulsion on the spring. Okay? But on the spring, it definitely experiences a pull by this gravitational force. It experiences the compression by this block. So there will be elastic spring force. So I would think the answer will be C and D. Alright, gravitational force and elastic spring force. So C and D. Answer should be 4. Okay, I hope that helps you. Take care.